Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be looking at making one of these. Now what this is based upon is something that I came across when I was teaching in further education. It's actually a valve system for a car engine that does away with the camshaft. What it's using is light-powered solenoids to actually drive the valves, and this was based upon something that was actually real. It was made by an apprentice and he was given the task of getting rid of the camshaft on a car engine because of course sometimes the cam belt can break and that causes an engine to blow up. And he came up with this very clever design utilising lasers to create the light and then light dependent resistors to receive the light and then subsequently drive the solenoids, which is great. Very, very clever idea, and using the disc on the left hand side there with a cutout. What he'd actually done was done it for a V8 engine. It was on a BMW engine and he actually did win an award for this design. Very, very clever man. But anyway, that's what we're about today. That's what we're looking at building. So without further ado, let's see if we can make this happen. I'm not going to build this one from scratch because all of the elements are very, very simple. Cylinders, splines and sweeps for the cables. Obviously cylinders here for the receivers and emitters. And the disc here, that was just basically an arc that I made into a sector and then essentially just extruded that and made the actual shape there. That's all I've done to make that. Nothing clever about any of this. And the valves themselves, again, they were just they started as cylinders and all I did, made them editable, added a cap segment and then extruded, threw them into a subdivision surface to make them smoother and a bit more valve-like, and then that was it. There's nothing clever about any of this really, so there's no point making it from scratch. What I will do though, I've just hit F4 to switch to a side view. I just want to just briefly go through the actual valve setup. So in my valve null is positioned here for my parent null, and you can see that I've turned it through 180 degrees in the rotation P here so that it's actually upside down. And that's essential because of course we want the valves to move from their initial position, which is if I click on this, actually let's do V2 because it's at its start position. So V2 is in the same position along the y-axis as the valve's parent null. Now that means it's starting from a 0 point in its position Y here, and we want it to reach 50 at its maximum position. And because these are set upside down and they're within a null that's already upside down, that means 0 to 50 works in the opposite direction to which it normally works, and that's essential. So that's the way you set your valves up. Your parent null, rotate it through 180 degrees, rotate your subdivision surfaces through 180 degrees, and then place them in the parent null, zero them out, and everything will work. So that's the way you do this. And obviously these are 100 apart. If I select V2 there, it's 100 units away from the previous valve. So they're 100 units apart along the x-axis. And that's all you need to do in order to make this work. But it was worth mentioning because if I hadn't have done it, could have caused a bit of confusion. Okay, so hopefully that's clear and then we can move on. In order to achieve all of this though, what we're going to be using is a combination of Expresso and a little bit of Python, but it's all going to be done in the Expresso editor, so we're going to be using the Python node in there. Okay, so that just about sets us up. Let's see if we can start making this happen. So we'll get a null and we'll name this Expresso. And then we can start adding some nodes when we get a tag on it. So let's just get an Expresso tag and we're ready to start work. We'll just move this over here and open it up and make it a bit bigger because there's going to be quite a lot going in here. The first thing I'm going to bring in is going to be an iteration node. Just place it there, and then our start will be 0, our iteration end will be 3. Obviously that's because we have 4 elements here, so we're going to be working from index values 0 to 3. We're going to be making extensive use of linked lists. In fact, we're going to be using 5 of those. For the moment, I'm going to bring in the first 3. So we'll come down to our general menu here and select linked list. And then I'll command drag to copy another couple of those. And our iteration we can plumb in straight away to our index inputs of the linked list nodes. Right, what's going to be going in each of our linked lists? Well, if we select the top one, this will be for our valves. So all of these are going to be going in this particular linked list. So I'll get the arrow and select those. And they're set up in there. And what we'll do, I'm actually going to rename the list so that we know which ones are which, as there's so many of them. So that can be called valves. The second one is going to be for our emitters. Now the emitters, what we've got, before we go there, let's just have a quick look at what we actually have. The emitters are our little objects here. They're just our cylinder objects. What they have, each of them has a null associated with it. And the null is actually going to be used to emit an invisible ray, because we're going to be using the ray collision node to actually make this work. Similarly with our receivers, we've got the same setup. So if we just move this round, we can see that R1 is over there, which is the cylinder object, and null number 4 is here at the tip of it. So that's there to receive the light ray when it's traveling through the gap in the disk here. And of course, when that's happening, that's the point at which the valve is going to be triggered, or the solenoid is going to be triggered to actually make the valve move. That's the way this setup is going to be working. And a little bit later, of course, we will actually put the light rays in so that we can see those. But the light rays themselves, they do nothing. They're just a visual representation of what's going on. The important thing is the invisible rays that are generated via the ray collision node. But that's what we're about here. Let's just move that back down there so we can see what we're doing. Right, I've done my usual trick. Let's just zoom into 100% and just set that back up. Right, so a second linked list then, we're interested in the nulls from our emitters. So we'll just click on there again and start putting those in. And that's those 4. And again, I'm going to rename this. So just rename it emitters. And then we can select our final linked list. And we'll take in the nulls from our receivers. And name this receivers. Okay, so that sets up the first 3 linked lists. Moving on from here, we can start thinking about what we're actually going to be doing with these. The first things we need to do are to bring in a null from our emitters here, and we'll also bring in null number 4 from our receivers. So we've got the first 2 in each of our lists. And then we can give both of them object ports. So we can put an object port on null, and also do the same with null 4. So they've both got object ports. The next thing we need to add at the output stages are global position output ports on both of those, because we're working with globals. That's very important. Okay. The next thing to bring in is our disk. And again, this can be given an object port, but this time at the output stage. And then our all important node, which is going to be the ray collision. So we'll bring that in. And our disk will be plumbed into the object port, because that's the disk, or the object I should say, that we're looking for our rays to collide with. And then we can plumb our nulls, output ports into ray points 1 and 2. So what we're doing is checking for a collision along the vector between the two nulls. We will also need to add a hit position port, which we're not going to be using initially, but we will need it later. So I'll add that now. Before we move on, we'll have a quick look at what we're doing. So we're going to scan through our valves, our emitters, our receivers, and we're going to pass the global positions of our emitters and receivers to our ray collision node in a sequence and check to see if any of them are making contact with our disk. That's what we're doing here. The valves, what we also need to do, we open our valves and we just grab a hold of V1. We can bring that in, and again we can connect our link to an object port at the input stage, and we also need another port there too, because we need that to be a position this time, but it's going to be position Y. Because obviously what we're going to be doing is moving our valves up and down, so it's position Y that we're interested in. So that gets that little part of it complete. So we're talking to everything, we've got everything sequenced, and everything is, we're checking for a ray collision, and we know that we've got our valves sequenced as well, so that if anything happens, the correct valve is going to be triggered at the correct time. That's as far as we've got so far. The next step is to check when our gap in our disk here is allowing a ray to pass through it. And we do that just using a compare node. So if we bring in one of those, come down to logic and grab a compare node, all we need to do is plumb the collision into input 1, and input 2 we can say in our node we've got our function at equal to, and our parameter is at 0. So equal to 0 is all we need to say in there, and that will tell us when we don't have a collision, and that's of course when our valves are going to be triggered. So that's that little bit of it sorted out. Moving on from here, we'll bring in a condition node, and we'll place this just over here. Move this over a little bit, and the output from this condition will be plumbed into the position Y. We'll leave our input 2 of the condition node, we'll leave that at 0. The switch is going to be controlled by the output from the compare, so we can plumb that in there. Now, what are we going to be plumbing into input 3 down at the bottom here? Well, that's where the all-important Python node comes in. So that's going to be the next step for us, is to start doing some Python programming. So we'll come down to script, bring in a Python node, and I'll do my usual thing of removing all the input and output ports. It's just delete port, and do the same again. And now we're ready to start work. So for this, I'm just going to open the Python editor. I won't bother going into a coding layout, we'll just go into the Python editor and set that up there. The first thing I'm going to do is come up to the top of the window here and say import utils. And it also helps if I put from C4D at the beginning. So from C4D import utils, and you've probably guessed if you've done any more of my Python tutorials that we are going to be using a range mapper here. Now you may well ask, why do we not just use a range mapper setup in the Expresso editor here with say a monoflop? Well, I tried it and there's a very simple reason why I'm not going to use it. It's because it don't work. Don't know why, but it just doesn't work. So the way I found to get around it was to use Python. So that's why we're using Python code. Let's just remove this line of code here. We do need global output 1, but we're going to call it something else. In fact, no, I'll tell you what, we won't. We'll leave it as global output 1. We'll just call it that. It doesn't really matter. It's only one output. We need to add some more global variables though. So we can say global trigger and global start underscore time. So they're ready for us. We're also going to be using a spline here, so we need to add some user data to our Python node, and we'll do that now. Actually, I'll just create the user data. So if I go over to my user data and say add user data, I can simply call this spline, select a spline there, and we can click OK, go into our user data, and we can just define this spline. We might as well do it now. It's going to be a simple bell curve, so we're just going to go like this, just get a second point up there, a third point over here, and then we'll do a little bit of work. So we'll just open the spline up. We'll make this 0.5 in the X and obviously 1 in the Y, and then we can just make an adjustment to the tangents. And the tangents, I'm going to say, it's going to bring these, and what have we got here? So I've got 0.25. If I make that 125, make this one minus 125 or 0.125, and this middle one, I'm just going to bring this out, just bring it out to sort of, oops, that's a mistake, make it 250, 0.25 actually. I think I'll make them all 0.25 because I think it will give us a better result. Yeah, actually I think that will look better. Let's just make them both 0.25 as well. Yeah, that should give us the result that we want, so I'll leave that at that. Go back into the node, and we can go back into our Python editor. Next thing I can do actually is bring in my spline data. So what I'll do is just grab a hold of this and drop it in and say spline equals op user data number 1, and that gets that sorted out, ready for us. Moving on from here, if frame is equal to 0. Now I also need to work out what I've got in here. Let me see, frame. Okay, frame is equal to 0. I need to actually add my input ports before I go on to this really, but I'm going to just do this. I was just going to say if frame is equal to 0, put this in here and then just type pass in there for the moment so that nothing happens. So let's just start adding some input ports here. I've just skipped a bit of a stage. Let's do that. So we want to say an integer because we're working with frames, and we can say rename port and call it frame. And next port, we're going to say integer again, and this will be called trig. So we've got frame and we've got trig, and I said that I would just use output 1, and I will use output 1. So we'll make that a float, and that will be called output 1, and that's fine. We'll leave that like that. So our ports are now set up and we can carry on. So apologies there, just skipped a stage for a minute. Right, so I can remove the word pass. At frame 0, I want trigger to just be an empty list, and I also want start time to be an empty list. So those are both set up there. I can then ask a question. So if trigger, or if trig rather, which is of course our port, so if there's something coming into this trig port here, if it's equal to 1, I can then say if len, and you've seen me do this before if you've done any of the other tutorials that involve this code, is less than 1, then I can say trigger dot append 1. If len start underscore time is less than 1, start underscore time dot append frame. So we're going to grab the current frame. And that completes that little bit of the code. And now we can work with our range mapper. So if len trigger is equal to 1, so if we've been triggered, duration is equal to frame minus start underscore time square brackets 0. So that sets us back to a 0 starting point no matter where we are along the timeline. We can then say if duration is less than 23, because I want this to happen over 23 frames, range mapper is equal to c4d.utils dot range map brackets duration, spell it correctly, duration, and it will be 0,23, so that's our input range, 0,50 for our output range, true because we're working with positive values as opposed to negative values, and spline because we want our spline to be our data mapping controller. So that's our range mapper set up. We can then simply say output 1 is equal to range mapper. And then to finish off, else trigger dot clear start time dot clear open close and output 1 equals 0. So at all times when the range mapper isn't being used, in other words when our valve here isn't moving, we want its position to be held at 0, and that's why we're putting this else in here with the output is equal to 0, output 1 is equal to 0. That's what that's doing. And that's as much as we need to do with the code to actually make this work. Okay, so provided I haven't made any errors, and I may well have done, you know that I always do, or quite often do, there'll probably be a typo. But anyway, for now, we'll say that's okay. And we can connect the output of our compare to the trigger. We can also bring in a time node. And as per usual, we'll add a frame port and delete the time port. And that's where we get our frame value from. So we can plumb that straight into there. And then the output from the Python node can be plumbed into the input number 3 of our condition. And then we can plumb the output into the position Y. And from here, we should now be able to start seeing some results. So let's see if we do. Let's just close this down and move this out of the way. And let's see what happens if we do this. Do we get anything at all? We're not. I'm not quite sure why that is. Let's just bring in the Python once again and just see if we've got anything in there that's going on. Do a little bit of debugging here and there. Let's just go into the node, open that up. Let's have a look, see what we've got. Make sure I've got no errors. I'll tell you what, let's just get the console open and go into Python here. Let's have a look, see if we get anything when we just do an execute of that. Nothing in the execute. So let's just play the timeline. Right, we're not getting anything. We've got no errors in the Python. I don't think it's the Python. Let's have a look what we've got here. So we're saying we've got something going on that we don't like. Oh, I've got equal range mapper there. What have I got that in there? Let's just take that away. That looks as if it could be an error that we don't need. Let's have a look. I've got form C4 in it. There we go. I knew I'd make a typo. I did say, didn't I? I told you. Okay, so we've got that done. Let's just see if we get any better results. Let's have a look. We need to go back to the beginning of our timeline. And let's just see if we get any more errors in the console there. Right, what have we got here? Trigger is not defined. Let's have a look. Have a look. Trigger. Global trigger. Trigger. Start time. Well, I'm afraid it is defined, but let's have a look. Which line is it? In line 18. Where are we? If trigger. And then trigger is less than 1. It certainly is defined. I don't quite know what's going on there. Let's go there. It doesn't like it though. Does not like it at all. Right, let's just close this down a second. Close this down. And I'll just bring in a result node. I just want to plug that into here. Right, there's nothing working in there at the moment. Let's just move this out of the way. Bring that back to 0. Well, that's improved things slightly with the condition node. The top of that isn't yellow anymore. Let's just go back. But there's still a problem with this Python node, which is very, very odd. I don't quite know what's going on there. Don't quite know what's going on. Let's just run the timeline. Now it's starting to work. Okay. Right, that seems to have solved the problem, which is interesting. Yeah. So now we're getting what we want. Yeah, this is very odd. This is something to do with Expresso. Having to plumb this output of the Python node into the result node. We've seen this before when using the monoflop node. It's very, very odd. There's definitely some kind of bug. I'm convinced there's a bug in Expresso somewhere that causes this. It really is very, very strange. But anyway, plumb the output of the Python node into the result node there, and you'll make it work if you get this problem. Great, so that's the crisis averted. Let's move on from here. To finish this off, we just need to bring in the elements that make the light rays visible. So what we'll do, I'll just close these for a minute and close the valves. And in light rays, I've got them here. Now they're currently switched off. Let's just make them visible and see what we've got. So the light rays, they're created, or the actual lights, I should say. These are the light rays, and these are the targets really for actually making this work. The null objects that we're going to use to actually make this work. Now, what we've got in each light, we've got a circle being swept over a spline in order to make the actual light ray visible. And what we're going to do is actually control the points of the spline. Each spline, if we go into our structure manager, they've just got 2 points. So point 1 of each of these splines is going to get its position from each of the null objects here. Currently the null objects are placed over here because none of this is set up to work yet. We've got to just plumb all that in and make it actually happen. But this particular null is going to be attached to this particular point when all of this is working, and the same will be repeated for all of the others. Okay, so that's how this is going to work. So that's all good. In order to make it happen, what we need to do is start creating some more linked lists. So let's just bring in a couple more of those, and we'll copy that one. And we can plumb in our iteration into the indexes for those two. Now the first one, this is going to be our null objects. So we're going to plumb those into our first linked list. So we'll grab a hold of our arrow and grab these in. They're not in numerical order. That doesn't really matter. because, well, I say it doesn't matter. Let's have a look and see what we've got here. So let's see what order they're in. So our first one is LR1, that's there. Our second is, let's just take away that a minute. So we've got LR1 for the first one. The second one is LR4. We don't want that. We want them in the proper order. So let's just reorder them. In fact, what we'll do, we just reorder them in the linked list. Make sure that we get them in the correct order, because we want them to be 2, 3 and 4. And that should be correct now. So we've got, if we just reorder them in here, we should be correct. So LR1, LR2 is the green, that's correct. LR3 is the blue, and LR4, that's correct. So those are all working as they should be. Moving on from here, let's just rename this, and we'll call this light rays. And the final linked list needs to contain our splines. So let's go and sort this out. So we'll call this one spline, and then in our node we can just grab in the splines that we need. So we need the ones from each of our sweeps there, and that's our splines dealt with and our light rays dealt with. So we can move on from here and see where we are. Let's just reset the timeline. Okay, we need another condition node, so we'll bring one of those in, and again the output will be switched by the output, or the switch I should say, of the condition node will be switched by the output of our compare. We also said that we wanted to use the hit position of the ray collision node at a later point in this, and this is the point at which we need to do that. So we want to plumb this into input 2 of the condition here. Okay, so when there has been a collision, we're going to get the hit position, and what we're going to do is actually get each one of these nulls and place them on the hit position of the disk here. So wherever these hit the disk, or to put it more correctly, wherever the ray collision detects a hit, whatever point that detects a hit at, that's where we want to place the null object that's going to be attached to the point 1 of the spline, and that will make the light rays behave exactly as they do in reality. Now when there's no position to actually hit, so in other words, when the light ray is able to pass through the gap in the disk object, at that point we want them to reach the receiver here, just the end of the receiver, and I happen to know that that's a value of 150. So in our parameter here we can put 150 in there, because if we go into our top view, all of these are grouped into light rays here, which is set, as we can see, level with the edge of the emitters. So that position is position 0 for all of the children within the object. So that means that 150 units away from here is where we want the final resting place of our light rays to be. So that's why that's set up that way. Hopefully that's clear. So that's our condition setup. So we're going to either use the hit position or we're going to put it at 150. Moving on from here then, what we need to do is bring in one of our light rays, and we'll bring that in here. And that will be, well, there'll be, again, it will need an object port because it will need to be passed a light ray from here. So they're going to be passed in sequence, as is everything else, and it will all be synchronized because of course it's being done by the same iteration node over here. This iteration is controlling absolutely everything, so they'll all be synchronized. And then we can drag out our output from the condition here and make this position this time, not global position, position X. And we'll just make that slightly bigger and put that above. Okay, so make that tidier. And at the output stage of here, we also need a global position output. So we'll put one of those there. So we're set up and ready for the next step. To finish this off, we just need 2 point nodes. So we'll bring those in. And we won't worry about the yellow top. That's not a problem. So we've got those two in there. They both need a point position port at the input stage. So we'll add those, make them a little bigger, and then we can drag them over to the right. We'll just move that over there. So that's fine. So that's set that up. Good. That's ready to go. Now, in order to finish, all we need to do then is from our spline here, we need to pass the output of the link to the input or the object inputs on both point nodes. We also need to set up the index value here to 1 in the second point node. And then to actually make it all work, we need to say that we want the global position output of the LR1 here. We need to plumb this into the point position of our second, or our point 1. So because we said that we'd be passing these positions to point 1, so that's why we're doing that. And it's global position because they're grouped into the light rays. That's why we need the global position. So we're passing that to there, and then finally we're going to use the global positions of our emitters here, because we said that the emitters over here have, and you can see that things are going on there, there's stuff's already working, but our emitters are over here, so that's going to be the start position for our light rays. So we can just say global position here, and we can take this and we can plumb it into the point position of our first point node there. And that's the finishing stage for this. Let's see what's happening, see if anything's working. Yep, and it is. It's not quite working the way I want it to though. Let's have a look and see what we've got. It is starting to work, but it's not 100% correct. Now let me see. Right, okay. What we might need to do, let's have a look. What have we got up here? Our emitters. We've got our null there. We've got that there. Well, it should be okay. Shouldn't be a problem. Let's just have a quick look, see if we've got any errors in there. It's interesting though, because it is doing what it's supposed to be doing, but the hit position doesn't seem to be doing its job in quite the way that I would want it to. So let's have a quick look. Make sure array collision is set up correctly. Ah, it's in test mode. Now that could be a problem. Let's take that off. We want it in global coordinates, but we don't want it in test mode. Aha! And now it's working. So if you get that problem, just check off the test mode and it should work fine. Okay, so let's just run that. And now you can see that it is behaving exactly as you'd expect it to. We'll just click on there so that we get rid of that object axis. Yeah, all working beautifully. Okay, and I've obviously set the disk up with some keyframes. So in the disk, if we go down to the bottom here, in our keyframes, if we just click on the keyframe, what I've done at frame 90, I've set it up at minus 356 degrees. Obviously, if we go back to 0 and we click on our keyframe there, it's just zeroed out. So if we're starting at 0 degrees and we're ending up at 356 degrees or minus 356 degrees at frame 90. So that's all you need to do in there just to get that disk moving in the way that you want it to move. If you're going to do it over 90 frames, obviously if you're going to use more than that or less than that, you've got to change things a little bit, but that's how that works. So yeah, all working really nicely. Let's just give that another run. Yeah. In fact, one thing that is wrong, have you spotted the deliberate mistake in it? It's not quite right, is it? Because the sequence that the valves are moving in is incorrect. Because it's set up in such a way that we need to actually put the valves slightly out of order. Let's have a look, see what we've got in there. So we're starting with V1, but V3 should be next because the green is next. And we're doing this like a car engine because obviously they don't run in numeric order. So V3 should be next, then V2 and then V4. And hopefully that should work properly now. Let's just see what we're doing. See if we get it. So we got the red, the green, the blue, and finally the yellow. That's correct. So that's all we needed to do there, was just reorder those in the link list. And yeah, it's all working really nicely. Hopefully what this demonstrates is the power of using an iteration, just a single iteration with multiple linked lists. The way that you can synchronize all of these individual elements and get them working in tandem together. This issue over here with having to plumb in a result node, this is frustrating, and I really do wish that Maxon would take a look at this and get it sorted out. But anyway, they haven't done at this moment in time, so such is life, I suppose. I mean, hopefully they will do some work on this in the future and resolve this issue so that we don't need to use this result node to sort things out anymore. I mean, you can try working over here in the X Manager and playing around in the X group and reordering things. I mean, I've done that when I did the original one. I optimized the expression and made it work as efficiently as I possibly could. It still didn't solve the problem. So there really isn't a lot you can do about it. But anyway, that is the whole expression. So there it is for you, laid out there. Yeah, I suppose it's quite an involved one compared to some that I've done. There's a little bit more going on in there. And plus, of course, you've got the Python as well. So you've got that to worry about. But again, it's simple code. There's not a great deal of complexity in there really. It's just simply a case of having replaced the monoflop and range mapper nodes within the Python editor with the code equivalent. That's all we've done here. So it's perfectly simple really. We haven't done anything particularly complicated and it just works in the same way. And as I said, the only reason I did it this way is because the standard monoflop and range mapper node method just wouldn't work in this particular instance. It's not particularly complicated compared to some of the ones that I have actually produced, but that's all there is to that. That just about completes the tutorial. So as I always say, I really do hope you've enjoyed this one. I've had quite a bit of fun bringing it to you. And if you have, then obviously please subscribe to the channel if you haven't already. Please give the video a like, and if you're on social media, wherever you happen to be, then please share the video because, of course, all this good stuff helps to keep the channel going in the right direction. But anyway, that just about wraps this one up, so I'll see you very shortly on the next tutorial.